All right. Hello, students. Welcome to our discussion on friction. I am Harsh Kapil. Now, in the previous discussion, we saw Newton's laws of motions and its application, how to draw the free body diagram, pseudo forces, and a lot of things were discussed in our previous class. However, I told you that I won't be discussing a lot of problems because one thing was missing was friction. Once we bring the friction in the picture, it complicates the problem and it also help you understand a different level of problems of the forces. Okay, Newton's laws of motion, pseudo forces, friction, a lot of things. When those are involved in a problem, then it becomes complicated, so you have to actually apply your brain at a different level. So that is why we did not discuss a lot of problems in the last discussion of Newton's laws of motions, all the four parts. Now let's discuss here in this chapter. Okay, we will discuss what is friction, what types of friction that we see, and it's the formula is not complicated, simple. But when we will jump into the problems, we will discuss a number of problems at different levels that will help you understand. Okay, so let's discuss here further. Okay, these are some institutional information where you can always get in touch with me for any kind of doubts or personal guidance program that I conduct. All right. Now, friction, what it is, we all know that. Okay, whenever we try to push something or pull something like a table or chair, okay, we are not able to easily pull or push it because the rough surface or rough floor is applying some friction. Okay, the floor is not perfectly smooth. That is why we are not able to pull or push it easily. That is why it is somewhere it is assumed to be a negative force, but it's not really that. Right now, if you see that you are holding a phone in your hand, it is only friction that is giving you a proper grip to hold your phone in your hand. Correct? So it is a supportive force. When you walk on a road or you run on a track, it is the friction that below your feet that helps you run and walk properly. So it is a supportive force also. Okay. However, normally if you try to push something forward, it friction will hold it backward. If you try to push something upward, okay, and the surface of that object is in contact with the rough surface, the surface will try to pull it downward. Okay, so that is why it is a negative force. Now, what types of frictions are there? You can just understand it by this example. When you try to push with a force a block lying on a floor, a heavy wooden block, as you can see here. When you apply small force, it doesn't move. Okay, fair enough. You keep on applying force, okay, because you want to move it forward. You reach to a level to when there was a maximum force you applied, and after that point, after that maximum force, it starts sliding or moving. Till that point, when it was not moving and it is about to move, the force, the friction force applied by the rough floor on this object, on this block, was a static friction. Why static? Static means the block is not moving. That is why it is static friction. Clear? Where is it applied? At the bottom of the block on the surface. Correct? Because that is in contact with the rough floor. It is a contact force. Okay. Now, after that particular point where it was about to move, okay, and after that point it starts moving, but you are still not able to move it easily, smoothly. Why? Because there is still some friction being applied by the rough floor on the block at the bottom of the surface. However, You don't have to apply that much force. Okay. Now, because the block you are able to move, that is in a kinetic mode, it is known as the friction applied by the rough floor on the block is known as kinetic friction. Correct. Now I said the force applied is not that high as it was earlier in the case of static friction when you were not able to move it at all. I will discuss it further. It's a microscopic thing, or molecular level understanding. Now when you are trying to roll a body like a tire or a wheel or a cylinder, as you can see here, okay, it has a very small surface, a line or a dot of a tire that is in touch with the floor, but still the friction is applicable. Okay, there is not much surface in touch with the rough floor, but still the friction is applicable. Why? Because the friction force is in proportion to the normal force applied by the surface on the object. You will see in the formula. Okay, it does not only depend upon the entire surface, however, it depends on the normal force applied by the floor on the object. If the object is heavy, the normal force will be more, the friction force will be more. Okay, now if the resistance, if in case you throw a ball inside a liquid or a water, okay, it does not even move properly inside water. When you jump inside a pool, swimming pool, okay, you feel light. Okay, why? Because there is a viscous force applied by the water or the fluid where you drop a ball. Okay, that is also a negative force, because that is you are trying to move downward, your weight is pulling you downward, but the viscous force applied by the water or the fluid is in the opposite direction, means in the upward direction. That is why you feel light. In the same way, if something is moving in the air, if you throw a ball, okay, the air resistance is applied by the molecules of the gases present in the air. So that is known as viscous force in the liquid and the resistance force in the air. Okay, that is also a kind of a friction force that is opposing the movement. Clear? Now let's keep our discussion to the static and kinetic friction to solve our problem. There is a simple formula for a static friction, that is mu s into n. Mu s means coefficient of friction is static. Now, when you are applying a small force, when the block you were not able to move lying on the floor, still there was some static friction. Okay, and it reaches to a maximum value till you were about to move it and the block was about to slip. Okay, so static friction's value keeps on varying and maximum is F max. Okay, so static friction is less than or equal to static F max is static friction maximum. Correct? Even if you're trying to push it, it's not moving. Okay, you increase the weight further, you increase the force further. Okay, still it is not moving, but still the friction force is acting. The friction force, static friction force, keeps on increasing to its maximum value F max. Okay, after that it becomes, when the block starts moving or sliding, it becomes kinetic friction. Okay, and where will be the direction? Opposite to the movement where you are trying to move it. If you are trying to move it forward, it is applicable in the backward direction. Where is it applicable? At the bottom of the surface of the block. Clear? Kinetic friction, after that particular point, maximum force, okay, when it just starts moving, okay, the kinetic friction comes in the picture. Okay, and what is the value? Mu k into n. Okay, it does not vary because you are able to slide it. Okay, So it's having a one value mu k. Coefficient of friction is mu k into n. Okay. Where is it? What is the direction? Opposite to the movement of always. Where is it applicable? At the bottom of the surface. Okay. At the bottom of the block at the surface. Where is it in touch with the rough floor? Clear? Now you can see here, as I said in the last slide also, that kinetic friction force is having less value in magnitude than the static friction. Now see in this picture, a block is in touch with the floor. Okay. You may assume that the entire surface of bottom of the block is in touch with the rough floor. But if you microscopically, if you see, the surface is like this, random. Okay. And the floor is also not having a straight horizontal smooth surface. It is having a rough random surface like teeth. Okay. So the concept that is applicable here is cold welding. Okay. They become jam packed over each other. Okay. These two surfaces. Okay. And they hold each other. Okay. The force, they try to hold it. Okay. You try to move it, they try to hold it. They oppose your movement. Okay. The force that you are applying. Okay. This holding force that comes in the picture is higher than when it was in motion, because this kind of holding force is not applicable when it becomes kinetic, or it is moving on the floor. The block is moving on the floor. There is no such holding force or cold welding comes in the picture. Okay. They are able to move it properly, but still rough surface is there that is applying the friction force opposite to the direction. That is why the kinetic friction is less than the value of the static friction. Did you get it? Okay. You don't have to apply much logic here, but simple thing is that they hold each other when they are lying on the surface. Okay. They hold each other surface. The cold welding concept comes, the bond. Okay. The force that comes in the picture, holding force. Okay. That is the reason why the static friction is more than the kinetic friction. Okay. Now see here, sorry, this example. Okay, whatever we have discussed, let's understand it by example, because friction in this chapter, the more problem you solve, the more you have understanding of Newton's laws of motion, pseudo forces, and the concept of friction and its value. Okay. In this example, you see here, there's a block of small mass m lying on the inclined surface of the wedge that is making an angle theta with the horizontal. The surface where the block is lying, the inclined surface, is having friction. Okay. Now, if the surface was smooth, what would have been the movement of the block if you leave it at the top? It will slide down. Okay. But there is a friction. It won't slide down. However, it will have a tendency to slide down. Okay. However, the friction force will try to oppose the movement and keep it static. Now, the question that is being asked is, find out the maximum value of the inclination theta max for which there comes no slipping in the picture. Means the block does not slide on the inclined surface. Means the friction force is able to hold the block on the surface. Okay, did you get it? Now, for that particular maximum angle, if the block is just about to move or slip, what kind of friction would be here? That would be static. Okay, because the block is not able to move, it is about to move beyond that inclination angle. Okay, the more you increase the angle, okay, the more tendency of the block would be to slide down. Correct? Less angle, the block won't be easily sliding down. More angle, increasing towards 90-degree angle, then the block would be having more gravitational force, its own weight pulling down. Correct? Now we know the static force. What is the maximum value is mu s into n, normal force multiplied by the mu s. Mu s is coefficient of static friction. Okay, you will use it. Now in our discussion on Newton's laws of motion, what was the first step? Was to draw the free body diagram. Okay, let's draw it here. This is the free body diagram of the block. Okay, normal force perpendicular to it, clear, perpendicular to the inclined surface, weight right downward, friction force opposite to the movement of the block. What is the direction of the block where it is having a tendency to move? Downward on the inclined plane. So the friction force would be acting in the opposite to it, means upward on the inclined plane. Correct? These will be the only three forces. Do you still have any doubt about it, or any other force that you can imagine here would be applicable? No other force. Normal force, its own weight, and the friction force, and the block is not moving. Okay, now what we will do, we will write down the equations of motion, sorry, the Newton's laws of motion. Second law, F is equal to ma. Since there is no acceleration, F is equal to total applicable forces on the block will be 0. A is equal to 0, then F is equal to 0. F is what? Total sum of the forces on the block. Now balance the forces in the x and y direction. Okay, this is our y and this is our x direction. We choose axis based on our convenience so that we can divide the forces and apply the Newton's law. Right, we have learned it already in the Newton's laws of motion and as well as in the projectile motion. In the x, in the y direction, in this direction, n minus mg cos theta is equal to 0. Correct? N upward, mg cos theta downward. Clear? In this direction, x direction, f is in the positive x direction, mg sin theta is in the minus x direction. So f minus mg cos theta. Put value of fs here and solve for theta, and it will come out as theta is equal to tan inverse mu s. So this is at this maximum angle theta, the block will, till this maximum angle theta, the block will remain at rest, and just beyond it, it will start moving and slipping downward. Okay, this is the simplified version of the friction problem. We will discuss more problem because this chapter is all about the problems. Okay, let's see one more problem here. Now you see in the first example here, there are the two blocks. Those are connected by a string over a pulley, light and massless pulley. Okay, the small mass M block is on the back side and the bigger block capital M is on the inclined plane, making an angle theta. Both the surfaces, horizontal and inclined, having the same friction mu, coefficient of friction mu. Okay, if you recall our discussion in the previous class of Newton's laws of motion, where I told you specifically here, if in case it is written in the problem or question that the pulley is massless, then what will be the tension at both the end of the string passing over the pulley? Same. Okay, so here tension at this end of the string as well as at this end of the string will be same. Okay, you can check our discussion on Newton's laws of motion on pulley. Okay, so tension here and here both will be same. Now the question asked is, what will be the maximum value of m, okay, for which system stays at rest if you keep on increasing mass of capital M block. Okay, so it will pull the smaller block small m as well. Okay, it will pull downward, the entire system will move forward and downward. Clear? So that is what is asked in the question, capital M by M. Okay, now what we will do, simple thing. Step 1, draw the free body diagram. Step 2, apply the Newton's laws of motion, or whatever equation of motion or Newton's laws of motion that is to be applied as per the question. Okay, now the free body diagram of the first block small m here is this. Normal force, say n1, in the upward direction perpendicular to the surface. Weight downward. If it is about to move forward, about to, not yet moved, because of the weight of the capital M, then the friction force will work in the opposite direction, means in the backward direction. Clear? Which is the pulling force? What is the pulling force? Tension in the string that is applicable in the up forward direction. Okay, is there any other force that is striking your mind is applicable here? No, these are the only four forces. Normal force, weight, tension is the pulling force, and the friction force that is opposing the movement. Okay, now we will draw the free body diagram of what? Second block, that is on an inclined plane, making angle theta. Weight downward, normal force, say n2, perpendicular to the surface. Okay, tension, pulling force here as per the string is in the backward direction. Block is capital M is about to move forward or downward here in this direction. In this direction, the friction force will oppose it. Where will it be applicable? In the opposite direction. Clear? Mu n2 will be applicable friction force. Now you have drawn the free body diagram of both the blocks. Okay. What is the next step? Write down the Newton's second law, F is equal to ma. Okay, because block is about to move, there is no acceleration, means F is equal to ma, then F is equal to a total sum of the forces on the body will be 0. Okay, write it here. T minus mu n1 is equal to 0 in the x direction. Balance the forces. In the y direction, n1 minus mg is equal to 0. Okay, these two equations from the first block's free body diagram. Here we will choose the x and y axis based on our convenience. What will that be? Let us choose like this, x and y. In the x-axis direction, write down the equation. Mg sine theta would be working in the positive x direction, and t and mu n2 both will be working in the minus x direction. So this will become your equation, mg sine theta minus t plus mu n2 is equal to 0. No acceleration, 0. Y direction, n2 is in the positive y direction, and mg cos theta in the negative y direction. So n2 minus mg cos theta is equal to 0. So you have all these four equations, correct? You know the value of the friction force mu n1 and mu n2 you have already applied in the equation here. Okay, you can solve these equations and find out the value of capital M by M. That will become like mu by sine theta minus mu cos theta. Okay, so this will be the maximum value of capital M by M, for which there would be no slipping. Okay, or it is about to move. Correct? You will be able to do it now. Now there is one problem that I am giving you to do it as a home assignment, and what is that is, solve this problem. These are the two blocks. Small block M is kept on a bigger block capital M. There is a friction between these two blocks, between the surfaces of these two blocks capital M and small m. However, the entire system or both the two blocks are kept on a smooth surface. The down where this entire system is put, that is smooth. Now, what is asked is what will be the maximum force applicable on the bigger block here, this one, so that the upper block does not slip over it, or both the blocks move together. What will that maximum force be? There must be no slipping and these two blocks must move together if we apply a force F max on the lower block. So you have to find out the maximum force. You have to apply, just giving a hint, you have to apply the concept of pseudo force, okay, here, and draw the free body diagram of both the blocks separately. You will be able to solve it. I will discuss, however, a complicated version of this problem in the next lecture. Okay. If you have any note, you can write down in the comment box. Thank you.